All right, we're taking this question from the 2016 General Maths paper, question 30, if I remember correctly. So there's a bit going on. This is worth 5 marks, so there's quite a bit to get through. Let's see how we go. Firstly, we've got a school playground. It's an odd shape. It's made up, it's what we call a composite shape because it's made up of a number of different shapes. If we want to get the area of the whole playground, we're going to have to work out the area of all these 3 different shapes. We've got a sector, the red one here. Okay, we're going to have to find the area of a sector. We've got a triangle here, so we're going to find the area of the triangle, but it's not a right angle triangle, so we may have to use some trigonometry for non-right angle triangles. And we've got a rectangle here. Now, if I can find the 3 separate areas, I can add them together. One important bit of info, though, is I can't find the area of that rectangle until I can work out the length of AB across here, okay? Because I'll need that to get the area of the rectangle. So that's going to be important. So let's have a look at that first. Let's see about how we can go about getting this. Now, I'm going to have to use the cosine rule here. I can't use the sine rule because I've only got one angle and there's no information about anything else. So I'm going to use the cosine rule, and if you've forgotten it, it'll be on your formula sheet. Here it is, a squared equals b squared plus c squared minus 2bc cos a. Now, I don't have any a's or b's or letters, and hopefully you remember the way I have taught you in class, if you're with me, is that rather than learning different variations, just think of it this way. The cos a, the angle bit, goes at the end, and it's the only angle that I've got. In this case, it's the 100 degrees. All right, let's just go back here for a second. All right, this is the only angle I've got in this triangle, so it's going to form the bit at the end. So effectively, that becomes my A. So I'm looking for then the side opposite that, which is the AB. What I want, okay, that forms the other end of my equation. So I've got the 2 ends, the angle and the side that we're looking for. The reason I do it that way is it doesn't matter what the others are. The B's and the C's, I can pick, it wouldn't matter which side I pick as the B or the C, okay? Because they're only being added or multiplied together, so it doesn't matter which order. In this case, they're both 45 anyway, so I've just filled in the rest of my formula using the side lengths of 45. That, to get from the AB squared back to the AB, I'll have to root both sides, and if I put that in my calculator, I get a value of 68.9. Awesome, we've worked out that length AB, and now that's going to come in handy for the rest of the question. Let's, for the moment, though, work on the sector, the red bit here. The area of a sector equals the angle that forms the sector divided by 360 times pi times r squared. Once again, that'll be on your formula sheet. I'm looking at this angle here. This is 260 degrees, and I know it's 260 because a full revolution is 360 minus the 100 that forms the bottom part, the yellow part of the triangle. So I'm left with 260 degrees at the center of my sector. So if I put that into my formula here, that replaces theta with 260. Now this just becomes something I can put in my calculator, and I get a value of 4594.58. Great, I've got the area of the red bit. Let's move on to the blue bit. This is nice and easy. This is a rectangle, and it's easy now because we worked out that length of AB. So I simply multiply the length times the breadth to get a value of 1378.88. Just the triangle to go. Now, having a look at this, it's not a right angle triangle. I'm not given a vertical height, so I'm thinking area equals half AB sine C. Okay, so let's apply that in this case. I've got the angle between 2 sides, so I can put all that into my equation. My A and my B are 45. My sine of C is the angle between them. Put that in your calculator, and you're going to get 997.12. We are almost there. All we need to do now is add together the 3 areas, the 3 separate pieces that we've calculated, and when I add them together, I'm going to get this value. But remember, very carefully, important to read the question carefully. It says we want it to the nearest meter, so I'm going to round that up to 6971 meters squared. 5 marks. 5 marks in your HSC. Good job.